June 16, 1944, Saipan, Mariana Islands. The morning mist clung to the volcanic ridges as Lieutenant Colonel Takechi Nagai adjusted his field glasses, studying the American landing craft streaming toward the beaches below. Behind him, 44 Type 97 Chiha medium tanks of the 9th Tank Regiment sat camouflaged beneath palm fronds and volcanic rock, their crews confident in what they believed would be another glorious victory against the supposedly inferior American forces. Nagai had read the intelligence reports from Tokyo. American tanks were crude, hastily built machines operated by inexperienced crews who lacked the warrior spirit of the Imperial Japanese Army. The Americans, soft from their decadent lifestyle, would crumble when faced with the disciplined fury of Japanese steel and the unbreakable will of the Emperor's finest tank crews. What none of them could have imagined was that they were about to witness the beginning of a technological and tactical revolution that would fundamentally transform Pacific warfare forever. The mathematics of destruction were already being written in American factories thousands of miles away, where Seabees worked around the clock to perfect weapons that would turn the jungle battlefields of the Pacific into furnaces of liquid fire. Within months, these same confident Japanese tank crews would face an enemy that could literally burn them out of positions they considered impregnable, wielding flames that could reach into the deepest caves and most heavily fortified bunkers with devastating precision. The transformation had begun years earlier in the industrial heartland of America, where engineers and military planners recognized a fundamental problem with conventional Pacific warfare. Japanese defensive positions, carved deep into coral and volcanic rock, could withstand massive bombardments from naval guns and aerial bombing campaigns that would have flattened European fortifications. Traditional infantry weapons, even tank cannons, proved inadequate against reinforced concrete bunkers and cave systems that honeycombed every strategic island from the Marshalls to the Philippines. The solution emerged from an unlikely collaboration between Navy construction battalions and Marine Corps tank crews who understood that winning the Pacific would require weapons specifically designed for the unique challenges of island warfare. While Japanese military planners focused on conventional tank versus tank combat, American innovators were developing something entirely different: mobile furnaces capable of delivering sustained streams of liquid fire with pinpoint accuracy. The first experiments began on Guadalcanal, where Marine Corps engineers mounted portable flamethrowers on light tanks, creating crude but effective weapons they nicknamed Satan. These early conversions used modified M3 Stuart light tanks with flamethrower units fitted into bow machine gun mounts, giving crews their first taste of mechanized flame warfare. The results were promising, but limited by the light tank's thin armor and small fuel capacity. Back in the United States, the Navy's construction battalions had been quietly revolutionizing military engineering since Pearl Harbor. These were not ordinary sailors, but skilled craftsmen, welders, electricians, and machinists who could build airfields from jungle swamps and repair damaged ships under enemy fire. When the call came for improved flamethrower tanks, the Seabees approached the challenge with the same innovative spirit that had already transformed American logistics throughout the Pacific theater. The technical specifications were daunting. Installing a flamethrower system in a Sherman tank required 1,200 man-hours of precision labor, with 1,100 electrical connections that had to be rewired and relocated throughout the vehicle. Each conversion consumed 150 pounds of welding rod and required 150 specially machined parts designed specifically for the flamethrower integration. The estimated cost reached $25,000 per tank, equivalent to several $100,000 in today's currency. But the investment was justified by the weapon's unprecedented capabilities. The Mark I flamethrower system could carry 300 gallons of thickened fuel, providing sustained fire for extended operations. The range extended up to 150 yards, allowing tank crews to engage enemy positions from distances that provided reasonable protection from return fire. Most importantly, the system could deliver continuous streams of flame for over 30 seconds, an eternity in combat that allowed operators to thoroughly saturate target areas. The fuel itself represented another technological breakthrough. Early flamethrower units used simple gasoline or diesel fuel, which created impressive visual effects, but lacked the adhesive properties needed for maximum effectiveness against fortified positions. American chemists developed napalm, a jellied gasoline mixture that stuck to surfaces and burned at temperatures exceeding 2,000 degrees Fahrenheit. This thickened fuel could penetrate into cave systems and bunkers, clinging to walls and equipment while consuming available oxygen and creating conditions that made survival impossible. Japanese intelligence services completely failed to anticipate this development. Their assessment of American military capabilities focused on conventional metrics like tank armor thickness, gun caliber, and mechanical reliability. They understood that Sherman tanks outclassed Japanese armor in direct combat, but they believed their superior defensive positions would neutralize American numerical and technological advantages. Cave systems and reinforced bunkers had proven virtually impervious to conventional weapons throughout the Pacific Campaign. The Type 97 Chiha medium tanks that formed the backbone of Japanese armored forces represented the pinnacle of Imperial Army tank design, but they were products of a military philosophy that emphasized mobility and offensive action over defensive warfare. Weighing 18 tons and armed with 47mm guns, these tanks had proven adequate against Chinese forces and early Allied equipment. However, their thin armor and limited ammunition capacity made them vulnerable to the improved American weapons appearing throughout the Pacific theater. Even Probel Moramatic were the Type 95 Heigo light tanks that equipped many Japanese units. These 8-ton vehicles carried armor less than 1 inch thick at their strongest points, making them vulnerable to virtually any American anti-tank weapon. Their 37mm guns could penetrate Sherman armor only under ideal conditions, requiring side or rear shots at close range. In head-to-head encounters, Japanese tank crews faced impossible odds against 30-ton Shermans with superior armor protection and devastating 75mm main guns. The Japanese High Command understood these limitations, but believed they could be overcome through superior tactics and fighting spirit. Their defensive strategy relied on forcing American forces into costly frontal assaults against prepared positions where numerical superiority would be neutralized by terrain advantages and defensive firepower. This approach had proven successful on Tarawa and other early Pacific battles, where American casualties mounted dramatically despite overwhelming material advantages. What Japanese planners failed to anticipate was the American capacity for technological innovation under combat conditions. While European warfare emphasized mass production of standardized equipment, Pacific operations demanded specialized solutions for unique tactical challenges. American forces demonstrated remarkable ability to identify problems, develop solutions, and implement improvements with unprecedented speed and efficiency. The Seabees embodied this innovative spirit perfectly. These construction battalions included skilled tradesmen who could machine precision parts under battlefield conditions, electrical experts who could rewire complex systems, and welders who could work with exotic materials in impossible circumstances. When confronted with the challenge of mounting flamethrower systems on Sherman tanks, they approached the problem with the same methodical precision they brought to building airfields and port facilities. The first successful Sherman flamethrower conversions emerged from Navy workshops in Pearl Harbor, where Seabee units worked around the clock to perfect the integration of flame systems with tank chassis. The complexity of the installation required complete rewiring of electrical systems, modification of fuel storage areas, and precise calibration of flame projection equipment. Every component had to function flawlessly under combat conditions, while maintaining the tank's basic operational capabilities. The testing phase revealed both the weapon's tremendous potential and the challenges of operating such complex systems in tropical environments. High humidity affected electrical connections, while coral dust infiltrated delicate mechanisms designed for more benign conditions. Salt air corroded metal components faster than anticipated, requiring constant maintenance and frequent replacement of vulnerable parts. These problems were solved through continuous refinement and improvement, with each operational deployment providing valuable feedback for future modifications. By early 1944, American forces possessed a weapon system that fundamentally changed the tactical equation throughout the Pacific theater. The Flamethrower Sherman combined the mobility and protection of America's most successful tank design with firepower specifically designed to neutralize Japanese defensive advantages. Unlike conventional weapons that relied on explosive force or kinetic penetration, flame systems could reach into spaces that no other weapon could affect. The psychological impact proved as important as the physical destruction. Japanese soldiers who had confidently withstood massive bombardments from naval guns and aircraft discovered that reinforced concrete provided no protection against liquid fire that could flow around obstacles and penetrate into the smallest openings. The flames consumed available oxygen, creating suffocating conditions that made even the deepest bunkers uninhabitable. The first combat deployment of flamethrower Shermans came sooner than anyone expected. As Lieutenant Colonel Nagai positioned his tanks for the counterattack on Saipan, 8 miles away in Pearl Harbor, the final Sherman conversion was rolling off the Seabees production line. The timing was purely coincidental, but it would prove historically significant. Within hours, these two forces, representing completely different military philosophies, would collide in the largest tank battle of the Pacific War. The Japanese plan was elegantly simple and tactically sound, according to conventional wisdom. The 9th Tank Regiment would spearhead a massive night assault designed to drive the American landing force back into the sea before they could establish a secure beachhead. Supporting infantry from the 136th Infantry Regiment would follow the tanks, exploiting breakthrough points and preventing American forces from organizing effective defensive positions. The attack would begin at midnight, when American air support was to favor the attackers. Nagai Ha unavailable, and confusion would studied every successful tank assault in Japanese military history. The rapid advance through Malaya, the breakthrough at Luzon, the devastating surprise attacks that had crushed Chinese armored formations throughout the war in China. Japanese armor succeeded through speed, coordination, and aggressive tactics that overwhelmed enemy forces before they could respond effectively. The Americans, despite their material advantages, had never faced a determined night assault by experienced Japanese tank crews operating on familiar terrain. The confidence was not entirely misplaced. Japanese tank crews possessed years of combat experience that American forces simply could not match. Many had fought in China since 1937, developing expertise in combined arms operations and night fighting techniques that gave them significant tactical advantages. Their mechanical knowledge of their vehicles was encyclopedic, allowing field repairs and maintenance under conditions that would disable less experienced crews. Moreover, the Japanese possessed detailed knowledge of Saipan's terrain that American forces lacked. Every ridge, every ravine, every potential hull-down position had been mapped and surveyed during months of defensive preparation. Tank routes had been carefully planned to maximize concealment, while providing optimal firing positions against American landing zones. The defenders knew exactly where American forces would concentrate and how they would likely respond to armored assault. What the Japanese could not know was that American tank crews had spent months preparing for exactly this scenario. Intelligence reports from Tarawa and other Pacific battles had provided detailed analysis of Japanese tank tactics and capabilities. American crews had practiced night fighting procedures, studied Japanese armor vulnerabilities, and developed countermeasures specifically designed to neutralize Japanese tactical advantages. The Sherman tanks positioned along the beachhead represented more than simple numerical superiority. These were M4A2 models, specifically configured for Pacific operations, with improved electrical systems that functioned reliably in tropical conditions and enhanced armor packages that provided additional protection against Japanese anti-tank weapons. Each tank carried high explosive rounds specifically designed to defeat Japanese armor, along with armor-piercing ammunition capable of penetrating any vehicle in the Imperial Army inventory. Supporting the Sherman tanks were M375mm self-propelled guns that provided additional firepower from concealed positions. These half-tracked vehicles combined the mobility needed for rapid repositioning with gun systems powerful enough to engage Japanese armor at extended ranges. Their crews had trained extensively in night fighting techniques, using illumination rounds and coordinated fire missions to maintain visibility during darkness. The American defensive position also included individual Marines armed with bazookas and 37mm anti-tank guns positioned in carefully prepared positions throughout the beachhead perimeter. These weapons, while individually less powerful than tank cannons, provided overlapping fields of fire that would force Japanese armor to expose themselves to multiple threats simultaneously. The integration of these various weapon systems created a defensive network that was far more formidable than its individual components might suggest. At 23:47 hours on June 16th, Japanese artillery began the preliminary bombardment that would signal the beginning of the assault. For 30 minutes, mortar and artillery fire rained down on American positions, creating the noise and confusion that Japanese planners hoped would mask the sound of approaching armor. The barrage was precisely timed to end just before midnight, providing maximum concealment for the advancing tanks while disrupting American defensive preparations. Lieutenant Jiro Tanaka, commanding the lead Type 97 in Nagai's formation, felt his pulse quicken as the artillery fire lifted. Through his periscope, he could see the orange glow of fires burning in the American beachhead. Smoke drifted across the battlefield, providing additional concealment for the advancing Japanese armor. Everything was proceeding according to plan. The Americans appeared disorganized and confused, exactly as predicted by the pre-battle intelligence assessment. The first Japanese tanks emerged from their concealed positions at precisely midnight, their engines muffled by special exhaust systems designed to reduce noise signatures. The Type 97 Chiha tanks moved in perfect formation, maintaining radio silence while following predetermined routes toward the American perimeter. Behind them, Type 95 Heigo light tanks provided flank security while infantry formations prepared to exploit breakthrough points. For the first 10 minutes, the assault proceeded flawlessly. Japanese tanks advanced through terrain they knew intimately, avoiding obstacles and maintaining formation integrity despite the darkness. American defensive fire seemed scattered and uncoordinated, exactly what Japanese planners had anticipated from inexperienced troops caught off guard by night attack. The lead elements reached within 300 yards of American positions without encountering serious resistance. Then the illumination rounds exploded overhead, turning night into day with brilliant magnesium flares that revealed every detail of the advancing Japanese formation. American forward observers had been tracking the assault from the moment the first tank left its concealed position, using sound detection equipment and night vision devices to plot exact locations and movement patterns. The illumination was perfectly timed to catch Japanese armor in the open with no available cover. The response was immediate and devastating. Sherman tank cannons opened fire simultaneously from multiple positions, their 75mm guns delivering high explosive rounds with pinpoint accuracy. The first Japanese tank exploded in a tremendous fireball as its ammunition magazine detonated, sending debris cascading across the battlefield. Two more Chiha tanks suffered direct hits within seconds, their thin armor providing no protection against American firepower. But the real shock came from weapons that Japanese intelligence had never anticipated. M375mm self-propelled guns emerged from concealed positions, their powerful cannons engaging Japanese armor at ranges that made return fire impossible. Individual Marines armed with bazookas targeted Japanese tanks from multiple directions, forcing the attackers to respond to threats from every angle simultaneously. The carefully planned assault degenerated into chaos as Japanese crews struggled to identify and engage targets that seemed to appear from nowhere. Lieutenant Tanaka's tank shuddered as a 75mm shell struck the turret, penetrating the armor and filling the fighting compartment with superheated fragments. His gunner screamed as molten metal burned through his uniform, while the driver frantically attempted to reverse toward the safety of Japanese lines. Around him, other Chiha tanks were suffering similar fates, their crews discovering that American gunnery was far more accurate than intelligence reports had suggested. The Type 95 Heigo light tanks fared even worse. Their 8-ton weight and minimal armor made them vulnerable to virtually every weapon in the American arsenal. Bazooka rounds that might only damage heavier tanks completely penetrated Heigo armor, destroying the vehicles and killing their crews instantly. Some tanks were hit by multiple anti-tank weapons simultaneously, their wreckage scattered across hundreds of yards of battlefield. Within 20 minutes of the first illumination rounds, the Japanese assault had collapsed completely. Of the 44 tanks that began the attack, only 12 survived to retreat toward Japanese lines. Even these survivors carried battle damage that would require extensive repairs before they could return to combat. The 9th Tank Regiment, once considered among the finest armoured units in the Imperial Army, had been effectively destroyed in a single engagement. The aftermath revealed the complete transformation of Pacific warfare that American innovation had achieved. Japanese tactics, that had proven successful throughout Asia, were suddenly obsolete when confronted with integrated defensive systems designed specifically to counter them. Night attacks, once a Japanese specialty, became suicide missions when faced with American illumination technology and coordinated fire control. The warrior spirit that Japanese commanders relied upon provided no protection against overwhelming firepower applied with scientific precision. Lieutenant Colonel Nagai, one of the few senior officers to survive the assault, wrote in his diary that night about the complete failure of Japanese assumptions regarding American military capabilities. The enemy possessed not only superior equipment, but tactical sophistication that exceeded Japanese estimates by enormous margins. Their defensive coordination was flawless, their gunnery was devastatingly accurate, and their integration of multiple weapon systems created killing zones that no assault could penetrate. But the Saipan tank battle was merely a preview of innovations that would fundamentally transform Pacific warfare. 800 miles away in Pearl Harbor, Seabees workshops were completing the final preparations for weapons that would make conventional armored combat irrelevant. The Flamethrower Shermans that would soon appear on Pacific battlefields represented more than simple technological advancement. They embodied a complete revolution in military thinking that would render Japanese defensive advantages meaningless. The Japanese High Command, analyzing the disaster at Saipan, reached conclusions that were both accurate and terrifyingly incomplete. They recognized that American tank crews possessed superior training and equipment, but they failed to understand the full scope of innovations being developed in American workshops. Their response focused on improving anti-tank defenses and developing new tactics for armored combat, preparations that would prove entirely inadequate for the challenges ahead. The real transformation began in workshops scattered across the Pacific, where Seabees electricians and welders worked 16-hour shifts converting ordinary Sherman tanks into weapons that would redefine the very nature of warfare. Master Chief Petty Officer Raymond Kowalski, supervising modifications at the Pearl Harbor Naval Yard, understood that he was witnessing something unprecedented in military history. The flamethrower systems his crews installed represented more than technological advancement. They embodied a fundamental shift in American strategic thinking that would prove more devastating than any conventional weapon. The technical challenges seemed insurmountable to anyone unfamiliar with Seabees ingenuity. Each Sherman conversion required complete rewiring of 1,100 electrical connections, everyone tested and retested to ensure perfect functionality under combat conditions. Hydraulic systems had to be rerouted to accommodate fuel reservoirs, while fire control mechanisms demanded precision calibration that exceeded peacetime manufacturing standards. The work was performed under tropical conditions that corroded tools and equipment faster than they could be replaced. Electricians mate first-class Anthony Ricci documented the process in letters to his wife that would later provide historians with detailed insights into the conversion procedures. The fuel storage system alone required 47 separate modifications to the Sherman's internal structure, each one designed to prevent catastrophic explosions if the tank suffered combat damage. Safety mechanisms had to function flawlessly while maintaining the weapon's operational effectiveness, a balance that demanded innovative engineering solutions. The napalm itself represented a breakthrough in chemical warfare that Japanese forces could never have anticipated. Unlike conventional flamethrower fuels that burned quickly and dissipated rapidly, the jellied gasoline mixture clung to surfaces with terrifying persistence. Laboratory tests revealed that napalm could maintain combustion temperatures exceeding 2,000 degrees Fahrenheit for over 10 minutes, creating conditions that made survival impossible in enclosed spaces. More significantly, the thickened fuel could flow around obstacles and penetrate into spaces that conventional weapons could never reach. Cave systems that provided complete protection from artillery bombardment became death traps when napalm flowed into tunnels and ignited available oxygen. The psychological impact on Japanese troops who witnessed these effects was profound and immediate, creating terror that no amount of military discipline could overcome. The first assault on Saipan, where American designated for the upcoming operational Flamethrower Shermans, where forces on Saipan had spent months preparing defensive networks specifically designed to with commanders' plan to test significant the new weapons against Japanese defensive positions that had proven resistant to conventional attack methods. The timing was coincidental, but historically, never imagining that their enemies stand American bombardment tactics such preparations meaningless. Seabees workshops were developing weapons that rendered completed 8 flamethrower conversions in time for the Saipan operation, 1,500 hours each one, representing nearly of precision labor by skilled craftsmen working under impossible deadlines. The finished tanks, 300 gallons, providing sustained fire capability, carried fuel loads of that exceeded anything previously deployed in combat. Range tests confirmed effective engagement distances up to 150 yards, allowing tank crews to attack Japanese positions from relatively safe distances. The psychological preparation proved as important as the mechanical modifications. Tank crews selected for flamethrower operations underwent specialized training that emphasized the unique characteristics of their new weapons. Unlike conventional tank gunnery that relied on explosive projectiles, flame warfare required sustained application of fire to achieve maximum effectiveness. Crews learned to methodically saturate target areas, ensuring complete destruction of enemy positions through systematic application of liquid fire. Lieutenant James Morrison, commanding one of the first Flamethrower Shermans, wrote in his combat diary about the profound responsibility he felt operating such devastating weapons. The ability to project sustained streams of fire into enemy positions created tactical opportunities that no previous weapon had provided, but it also raised moral questions that conventional warfare rarely presented. The deliberate application of fire against human beings represented a form of combat that challenged traditional concepts of military honor. Japanese defensive preparations on Saipan reflected years of experience fighting American forces throughout the Pacific Theater. Engineers had carved elaborate tunnel systems into volcanic rock, creating interconnected defensive networks that could withstand massive bombardments while providing concealed movement routes for defenders. These positions had proven virtually impregnable during previous battles, forcing American forces to accept enormous casualties while reducing individual strongpoints through costly frontal assaults. The cave systems represented particular challenges for conventional weapons. Artillery shells that could destroy surface fortifications had minimal effect against positions carved deep into solid rock. Infantry assaults against cave mouths resulted in horrific casualties as defenders fired from concealed positions with overlapping fields of fire. Even tank cannons proved inadequate against reinforced positions that could absorb direct hits without suffering significant damage. Colonel Takeshi Yamamoto, commanding Japanese defensive forces on Saipan's central sector, had studied American tactics throughout the Pacific campaign and believed he understood their limitations. American forces relied heavily on firepower superiority, using massive bombardments to soften defensive positions before launching infantry assaults. This approach had proven successful against conventional fortifications, but showed diminishing returns against properly prepared cave systems and underground defensive networks. Yamamoto's confidence was based on solid tactical analysis supported by extensive combat experience. His troops had spent over a year preparing their positions, using forced labor and engineering expertise to create defensive networks that exceeded anything previously constructed in the Pacific Theater. Every cave mouth was protected by multiple firing positions, while tunnel systems provided concealed routes that allowed rapid reinforcement of threatened sectors. The Japanese defenders possessed detailed knowledge of American tactical preferences that seemed to confirm their defensive advantages. Previous battles had demonstrated that American forces avoided costly frontal assaults whenever possible, preferring to use firepower and maneuver to reduce defensive positions systematically. This predictable approach allowed Japanese commanders to position their forces advantageously while preparing countermeasures against expected American tactics. What Yamamoto could not anticipate was the revolutionary nature of the weapons approaching his positions aboard American landing craft. Intelligence reports from captured American equipment had provided detailed information about Sherman tank capabilities, but no Japanese analyst had imagined that American engineers could mount sustained flame projectors on armored vehicles. The concept was so alien to Japanese military thinking that it never appeared in defensive planning documents. The first hint of American innovation came during preliminary bombardments, when observers reported unusual modifications to some Sherman tanks, visible on landing craft approaching the beaches. The modifications appeared to involve additional fuel storage and unfamiliar mechanical systems, but Japanese intelligence officers dismissed these observations as routine maintenance equipment. The possibility that Americans had developed entirely new weapon systems seemed remote, given the conservative nature of their previous tactical approaches. On June 20th, 4 days after the failed tank assault that had decimated the 9th Tank Regiment, American forces launched coordinated attacks against Japanese cave systems that had resisted previous reduction attempts. The attacks began conventionally with artillery preparation and infantry reconnaissance, following patterns that Japanese defenders had observed throughout the Pacific Campaign. Colonel Yamamoto positioned his forces according to established defensive doctrines, confident that his prepared positions would exact enormous casualties from American attackers. The first flamethrower Sherman approached Japanese positions at 0730 hours, its unusual silhouette partially concealed by morning mist and smoke from burning vegetation. Sergeant Hiroshi Tanaka, manning an observation post overlooking the American approach route, noted the tank's strange configuration in his sector report, but assumed it represented some form of engineering vehicle. The possibility that he was observing a revolutionary weapon system never occurred to him. At precisely 7:45 hours, the Sherman stopped at a range of 120 yards from the cave system that housed Yamamoto's command post. For 30 seconds, nothing happened as the tank crew made final preparations for their inaugural combat employment of the flamethrower system. Japanese defenders watched curiously as the unusual Sherman remained stationary, its main gun trained on their positions, but not firing. Then, hell erupted from the tank's modified turret in a stream of liquid fire that defied every assumption about American tactical capabilities. The napalm struck the cave mouth with devastating accuracy, flowing into tunnels and igniting everything combustible within the defensive network. The flames reached temperatures that made steel glow cherry red, while consuming oxygen faster than human lungs could extract it from the superheated air. Sergeant Tanaka's final radio transmission described conditions that seemed impossible to anyone unfamiliar with napalm warfare. The liquid fire flowed like water but burned like the sun itself, creating heat that melted equipment and ignited materials that should have been fireproof. Concrete walls cracked from thermal shock, while steel reinforcements warped and buckled under temperatures that exceeded their design limitations. Within minutes, the cave system that had resisted weeks of conventional bombardment was completely uninhabitable. Japanese defenders who attempted to escape through tunnel systems discovered that napalm had flowed into secondary positions, creating furnace conditions that made movement impossible. Those who remained in primary positions faced suffocation as flames consumed available oxygen faster than ventilation systems could replace it. The psychological impact spread far beyond the immediate target area. Japanese troops in adjacent positions watched in horror as flames poured from cave mouths like volcanic eruptions, creating visual effects that seemed supernatural in their intensity. The screams of men trapped in burning positions carried across the battlefield, creating panic among defenders who had never experienced anything comparable to napalm warfare. Colonel Yamamoto, observing from a secondary command post, immediately understood that American forces had deployed weapons that rendered his defensive preparations obsolete. The carefully prepared cave systems that represented months of engineering effort had been neutralized in minutes by a single tank carrying unfamiliar equipment. His urgent radio reports to higher headquarters described American capabilities that seemed impossible, but were undeniably effective. The success of the first flamethrower attack triggered immediate tactical adjustments throughout the American sector. Infantry units that had been preparing for costly assaults against prepared positions suddenly found their objectives neutralized by sustained application of liquid fire. Tank crews reported complete destruction of defensive networks that had previously required coordinated attacks by multiple units over extended periods. More flamethrower Shermans were brought forward as word of their effectiveness spread throughout the American command structure. Each's devastating attack demonstrated the weapon capabilities against targets that conventional weapons could not effectively engage. Cave systems, reinforced bunkers, and tunnel networks that had channeled American forces into killing zones became death traps for their Japanese occupants. The tactical revolution was immediate and complete. Japanese defensive advantages that had dominated Pacific warfare for 3 years were suddenly neutralized by weapons that could reach into previously secure positions. The psychological impact proved as devastating as the physical destruction, creating panic among Japanese forces who discovered that their most protected positions offered no safety against American innovation. By evening of June 20th, American forces had advanced further in 8 hours than they had managed in the previous 4 days of conventional operations. The flamethrower Shermans had eliminated defensive positions that would have required weeks to reduce through traditional siege warfare. Japanese resistance, while still determined, lacked the coordinated defensive networks that had previously channeled American attacks into predetermined killing zones. The transformation of Pacific warfare had begun with 8 converted Sherman tanks carrying weapons that Japanese intelligence had never imagined. Within days, urgent requests flooded back to American production facilities, demanding immediate acceleration of flamethrower tank construction. The weapon that had started as an experimental solution to tactical challenges was rapidly becoming the most sought-after equipment in the Pacific theater. Lieutenant Colonel Yamamoto's emergency radio transmission to divisional headquarters at 1900 hours painted a picture of tactical obsolescence that senior commanders refused to accept. The Americans possess flame weapons mounted on armored vehicles that can penetrate any defensive position. Our cave systems provide no protection. Request immediate reinforcement and anti-tank weapons capable of engaging these new threats. The response from General Saito's staff reflected the institutional blindness that would characterize Japanese reaction to American innovation throughout the remaining Pacific campaigns. Maintain defensive positions. American flamethrower units are limited in number and fuel capacity. Continue resistance according to established doctrine. This dismissive response revealed the fundamental failure of Japanese military leadership to comprehend the strategic implications of what they were witnessing. The flamethrower Sherman represented more than tactical innovation of warfare that rendered. It embodied a complete transformation, traditional defensive thinking obsolete. The technical specifications alone should have triggered alarm throughout the Japanese command structure. Intelligence reports describing tanks carrying 300 gallons of jellied fuel with effective ranges exceeding 150 yards represented capabilities that no defensive doctrine could counter. Yet senior officers continued to believe that American innovations were temporary expedients that superior Japanese fighting spirit could overcome through traditional methods. This institutional denial extended to the highest levels of Imperial General Headquarters in Tokyo, where staff officers dismissed Pacific reports as exaggerated accounts from demoralized field commanders. The concept that American industrial capacity could produce revolutionary weapons faster than Japanese forces could develop countermeasures seemed impossible to military leaders who had built their careers on assumptions of Japanese technological superiority. The reality was far more devastating than Tokyo understood. In workshops across the Pacific, Seabees units were accelerating production schedules to meet urgent requests from field commanders who had witnessed flamethrower effectiveness firsthand. Master Chief Kowalski's Pearl Harbor facility alone was completing 2 tank conversions daily, while similar operations in Australia and California were ramping up to industrial-scale production that would dwarf initial prototype efforts. Each completed flamethrower, Sherman represented 1,200 hours of precision craftsmanship, but American industrial efficiency was reducing these timelines through improved techniques and specialized tooling. Electrical mate Ricci's innovation in prefabricated wiring harnesses cut installation time by 30%, while machinist mate Johnson's standardized mounting brackets eliminated custom fabrication requirements that had slowed early conversions. The fuel production represented an equally impressive achievement in rapid industrial mobilization. Napalm manufacturing facilities that had existed only on paper 6 months earlier were producing thousands of gallons daily by summer 1944. The 43rd Chemical Laboratory thickened fuel to support continuous company's plant in Hawaii, alone generated sufficient operations by an entire armored battalion, while mainland facilities prepared for production levels that would support the planned invasion of Japan. Quality control procedures developed under combat conditions exceeded peacetime manufacturing standards through necessity rather than regulation. Every electrical connection was tested twice. Every mechanical component was stress tested beyond operational requirements, and every fuel system underwent pressure testing that simulated combat damage scenarios. The reliability standards emerged from brutal field experience where equipment failure meant death for tank crews operating in the most dangerous environments imaginable. The psychological transformation of American tank crews proved as significant as the mechanical modifications to their vehicles. Lieutenant Morrison's diary entries from late June 1944 documented the evolution from conventional tankers to specialized flamethrower operators whose tactical thinking transcended traditional armored warfare doctrines. We are no longer tank crews in the conventional sense. We are engineers of destruction who can reach into places where no other weapon can touch the enemy. This philosophical shift reflected deeper changes in American military thinking that Japanese intelligence completely failed to detect. The Flamethrower Sherman crews were developing tactics that integrated mobility, protection, and sustained firepower in combinations that had never existed in military history. Their ability to methodically reduce defensive positions while remaining relatively protected from return fire created tactical opportunities that traditional tank warfare could never achieve. The combat reports flooding back to American headquarters revealed effectiveness statistics that seemed impossible even to friendly observers. Individual flamethrower tanks were accomplishing in hours what conventional forces required days or weeks to achieve. Cave systems that had resisted artillery bombardments equivalent to entire World War I offensives were being neutralized by single tanks carrying specialized equipment operated by crews who had learned their trade under fire. More significantly, the psychological impact was spreading far beyond immediate target areas. Japanese troops throughout Saipan were abandoning prepared positions rather than face the possibility of flamethrower attack. Defensive networks that had required months to construct were being evacuated based on rumors that American flame tanks were operating in adjacent sectors. The mere possibility of encountering liquid fire was proving more effective than actual combat engagement. Colonel Yamamoto's situation reports from late June documented the complete breakdown KOH of defensive vision that flamethrower operations had triggered throughout his sector. Troops are abandoning positions that have never been directly attacked by flame weapons. The psychological impact of these new American tactics is destroying unit discipline faster than enemy action. Request permission to withdraw to secondary defensive lines before complete collapse of organized resistance. General Saito's response revealed the strategic blindness that would characterize Japanese leadership throughout the remaining Pacific campaigns. Maintain positions at all costs. American flame weapons are propaganda tools designed to create panic among our forces. The Emperor expects every soldier to die at his post rather than retreat before enemy innovations. This delusional assessment of American capabilities would contribute directly to the catastrophic losses that Japanese forces suffered throughout the Marianas Campaign. The truth was that American innovation had fundamentally altered the tactical balance throughout the Pacific theater in ways that Japanese doctrine could not address. The Flamethrower Sherman represented more than improved equipment. It embodied a systematic approach to problem solving that identified challenges, developed solutions, and implemented improvements with unprecedented speed and efficiency. This methodology was being applied across every aspect of American military operations, creating cumulative advantages that Japanese forces could not match. The technical evolution continued even as early flamethrower tanks were achieving tactical success on Saipan. Seabees engineers were developing improved fuel systems that extended range and increased accuracy while reducing mechanical complexity. Electrical systems were being refined to function reliably in tropical conditions that had challenged early installations. Fire control mechanisms were being enhanced to provide precision targeting that maximized fuel efficiency while ensuring complete target destruction. The most significant advancement involved the development of external hose systems that allowed ground troops to direct flame attacks from protected positions while tanks remained in hull-down positions. This innovation, suggested by Marine infantry who had observed flamethrower operations, extended effective engagement range to over 400 feet while protecting both tank crews and infantry operators from return fire. The tactical flexibility provided by these systems revolutionized American assault procedures throughout the Pacific. Staff Sergeant Robert Chen, commanding one of the first tanks equipped with the extended hose system, reported unprecedented tactical flexibility during operations on northern Saipan. "We can position tank in complete safety while Marines direct flame attacks against targets that would be impossible to engage with conventional weapons. Cave systems that extend hundreds of feet into solid rock are completely accessible when we can snake hoses through tunnel entrances and sustained applied flame throughout the entire network." The logistical implications of widespread flamethrower deployment were staggering even by American standards. Fuel consumption during active operations exceeded 10,000 gallons daily for a single battalion, requiring dedicated supply ships and specialized handling equipment that had to be developed simultaneously with the weapons themselves. Ammunition requirements remained minimal since flamethrower tanks retained their conventional main guns, but spare parts and maintenance supplies demanded entirely new logistics categories. The maintenance requirements proved particularly challenging in tropical environments where salt air and high humidity accelerated wear on complex mechanical systems. Tank crews became expert mechanics through necessity, learning to perform repairs that would have required depot-level facilities in peacetime conditions. The reliability of flamethrower systems under combat conditions exceeded all expectations, but sustaining operations required maintenance procedures that pushed crew capabilities to their limits. Electrician's mate Ricci's technical reports documented innovations that emerged from combat necessity rather than formal engineering development. Waterproofing techniques that protected electrical systems during amphibious operations, corrosion prevention methods that extended component life in tropical conditions, and field repair procedures that restored operational capability using improvised materials. These battlefield innovations were incorporated into production specifications, creating continuous improvement cycles that enhanced weapon effectiveness. The Japanese response to flamethrower deployment revealed the institutional limitations that would plague Imperial forces throughout the remaining Pacific campaigns. Rather than developing countermeasures or adapting defensive tactics, Japanese commanders continued to rely on traditional approaches that had proven inadequate against American innovation. Orders from higher headquarters demanded that troops maintain positions regardless of tactical circumstances, creating situations where organized units were systematically destroyed by weapons they could not effectively engage. Technical analysis of captured Japanese documents revealed that intelligence services had identified flamethrower tank capabilities within weeks of their first deployment, but had failed to communicate this information effectively throughout the command structure. Reports describing American flame weapons were dismissed as exaggerated accounts from demoralized field units, while staff officers in Tokyo continued to base strategic planning on outdated assessments of American capabilities. The consequences of this intelligence failure became apparent during subsequent Pacific operations, where Japanese forces continued to employ defensive tactics that flamethrower weapons could easily defeat. Cave systems remained the primary defensive methodology, despite clear evidence that liquid fire could neutralize such positions with minimal effort. Underground tunnel networks continued to be constructed according to specifications that made them vulnerable to flame attacks that could penetrate throughout entire defensive complexes. More significantly, Japanese industrial resources were being allocated to defensive preparations that American innovation had already rendered obsolete. Concrete fortifications that could withstand conventional bombardment provided no protection against napalm that flowed around barriers and ignited everything combustible within enclosed spaces. Steel reinforcements that deflected artillery shells melted under sustained flame application that exceeded the thermal limits of any construction material. The strategic implications extended far beyond individual battles to encompass the fundamental nature of Pacific warfare itself. Japanese defensive advantages that had dominated early Pacific campaigns were being systematically eliminated by American weapons that could engage targets regardless of terrain or fortification strength. The tactical initiative was shifting irreversibly toward forces that possessed the technological flexibility to develop specialized solutions for unique operational challenges. American commanders recognized that flamethrower operations represented more than tactical innovation. Lieutenant General Holland Smith's assessment of Saipan operations emphasized the revolutionary nature of flame warfare and its implications for future Pacific campaigns. The flamethrower tank has eliminated Japanese defensive advantages that have cost us enormous casualties throughout the Pacific. We can now engage enemy positions that were previously impregnable, reducing them systematically without exposing our infantry to the horrific losses that characterized earlier operations. The production priority assigned to flamethrower tanks reflected their strategic importance in American planning for subsequent Pacific operations. Secretary of War Patterson's decision to grant AAA procurement priority placed flamethrower production on the same level as the Manhattan Project and B-29 development, recognizing that these weapons were essential for reducing casualties during future amphibious assaults. This priority ensured that American forces would possess overwhelming flamethrower capability during operations against increasingly fortified Japanese positions. By August 1944, flamethrower Sherman production had reached industrial scale with facilities in California, Hawaii, and Australia, completing tank conversions faster than Japanese intelligence could track. The standardization of conversion procedures reduced installation time to 800 hours, while improving reliability and operational capability. Quality control standards developed under combat conditions ensured that every tank met specifications that exceeded peacetime manufacturing requirements. The tactical doctrine emerging from Pacific flamethrower operations was being incorporated into training programs throughout the American military system. Tank crews destined for Pacific deployment received specialized instruction in flame warfare techniques, while infantry units learned to coordinate with flamethrower tanks in combined arms operations that maximized the effectiveness of both weapon systems. The integration of flame tactics into conventional military doctrine represented a fundamental evolution in American strategic thinking. The psychological impact on Japanese forces was becoming a strategic factor that American planners incorporated into operational assessments. Intelligence reports documented widespread abandonment of defensive positions based solely on rumors of flamethrower deployment, while prisoner interrogations revealed that fear of flame attack was affecting Japanese morale more severely than conventional bombardment. The terror weapon designation that American newspapers applied to flamethrower tanks reflected psychological realities that were proving as valuable as their physical destructive capability. Japanese attempts to develop countermeasures revealed the limitations of their industrial and technological capabilities when confronted with American innovation. Proposals for extended-range anti-tank weapons that could engage flamethrower tanks before they reached effective firing positions required manufacturing capabilities that Japanese industry could not provide under wartime conditions. Alternative defensive strategies that might have reduced flamethrower effectiveness demanded tactical flexibility that Imperial Army doctrine discouraged among field commanders. The failure to adapt represented more than tactical rigidity. It reflected fundamental differences between American and Japanese approaches to military problem-solving that would determine the outcome of the Pacific War. American forces demonstrated consistent ability to identify challenges, develop solutions, and implement improvements rapidly under combat conditions. Japanese forces showed remarkable courage and determination, but lacked the institutional flexibility to adapt when traditional methods proved inadequate against innovative opponents. The transformation was accelerating beyond Japanese comprehension. In workshops across the Pacific, American innovation was producing weapons that would fundamentally redefine the nature of warfare itself. The flamethrower Sherman had proven its devastating effectiveness on Saipan, but this was merely the beginning of a technological revolution that would render Japanese defensive doctrine completely obsolete. Master Chief Petty Officer Samuel Rodriguez, supervising flamethrower conversions at the Subic Bay facility in the Philippines, understood that his crews were witnessing something unprecedented in military history. The demand for converted tanks was overwhelming production capacity faster than additional facilities could be constructed. Every completed conversion represented not just mechanical achievement, but tactical superiority that Japanese forces could never match through conventional means. The technical specifications were being refined continuously based on combat reports flooding back from frontline operations. Range accuracy was improved through modified nozzle designs that concentrated flame streams while reducing fuel consumption. Electrical systems were hardened against tropical conditions that had challenged early installations. Fire control mechanisms were enhanced to provide instantaneous response times that maximized tactical flexibility during combat operations. The most significant advancement involved integrated communication systems that allowed flamethrower tanks to coordinate with infantry units and conventional armor in real-time battlefield conditions. Tank commanders could receive directing supporting fire's forward observers while simultaneously during operations on T environments. This integration creatinine documented the evolution of tactics D and could not effectively complex tactical combined arms capabilities target information from that Japanese forces had never encountered. Situational awareness throughout Michael O'Brien, commanding and maintaining situation, a flamethrower Sherman counter, lieutenant experience rather than formal doctrine that were emerging from combat development. His crews had Japanese positions undetected, delivering itself was undergoing continuous learn-to-use terrain features and concealment to approach formulations were being refined to increase spread far beyond immediate target areas. The fuel-devastating surprise attacks that eliminated defensive networks before defenders could organize effective resistance improvement through chemical research conducted under combat conditions. Napalm adhesion properties while extending as valuable as the physical destruction, creating panic that the psychological impact was proving burn duration beyond tests revealed that improved fuel mixtures could maintain initial specifications. Laboratory combustion temperatures exceeding 2,500 degrees Fahrenheit for over 15 minutes, creating conditions that made survival the systems and space. More importantly, the any chemical, more enclosed cave impossible ineffectively, engineered to flow being engine positions that conventional through complex tunnel networks. Characteristics were reach. The flowing fuel waves reduce weapons could never add it defensive viscosity, while maintaining adhes allowing if properties, nay precisely calibrated to ensure palm to penetrate into complete saturation of target areas while preventing waste through inefficient application methods. Japanese elitist propaganda designed levels too late to influence superiors, dismissed as deft reports describing an army, on beginning to comprehend the scope, the intelligence of American flamethrower deployment, but their SS intelligence services were finally defensive preparations. Colonel Muntz reached Common American Flame Capabilities Intelligence Officer for the 32, Chief Masataka Yamada Okinawa, submitted to undermine Japanese fighting spirit, that his institutionally UNW was accurate butelcum. American forces were numbers that exceeded Japanese estimates scale, while facilities across margins. Production by enormous the Pacific were completing deploying flamethrower tanks, entrained in conventional past original developing that conversions at industrial that relied on fort specifications ind range H improved versions doctrines. Extend for defensive forces. The tactical implications were staggering every measurable category Americ. And material advantages, ified positions to counter warfare. American innovations that seemed impossible to officers. Yamada's reports documentio systems that allowed flame capabilities. Combined conventional explosive apply mobile fuel exceeding 400 feet. Attacks from distances that enable represented systematistical constraints sustained operations without log supply vehicles. Specialized ammunition that these developments threw of shull effects with flame projection tactical challenges. Solution alone statistics, flamethrower tank, rather than theoretical military have triggered fundamental science. The production changed engineering. American and Japanese strategic planning. 5 production was approaching 100 complete across. Pacific all facilities 1,000 gallons daily from makings, while napalm manufacturing 50, ailed major multiple tactical expedients exceed supporting these operations, riv industrial undertestical infrastructure, chemical warfare that plants. The log commitment transcended temporary response revealed institutional to flame demonstrating American. The Japanese eyes their military limitations that would characterize performance throughout the remaining Pacific campaigns. Rather than adapting defensive strategies to counter flamethrower capabilities, imperial conversions, monthly army doctrinified positions, and underground continued to emphasize fort defensive networks that flame weapons could easily neutralize. The psychological inability to acknowledge American technological superiority prevented effective countermeasure development when adaptation might still have influenced tactical outcomes. Technical analysis of captured American equipment provided detailed specifications of flamethrower capabilities, but this information was not effectively distributed throughout the Japanese command structure. Field commanders continued to employ defensive tactics based on outdated assessments of American weapons, while staff officers in Tokyo dismissed intelligence reports as exaggerated accounts from demoralized frontline units. The laughter had died in the jungles of Saipan, replaced by the roar of liquid fire that consumed everything Japanese military doctrine had considered sacred. Lieutenant Colonel Nagai's confident predictions about American weakness lay buried beneath the twisted wreckage of 44 destroyed tanks, while 8 converted Sherman flamethrowers had rewritten the fundamental rules of Pacific warfare in a matter of hours. The transformation was complete and irreversible. American industrial might had not merely produced superior weapons, but had created an entirely new category of warfare that rendered Japanese defensive advantages meaningless. From the volcanic caves of Saipan to the coral atolls stretching across the Pacific, no fortification could withstand the systematic application of jellied fire delivered by tanks that combined American engineering precision with Seabees innovation. The flamethrower Sherman had become more than a weapon. It presented the manifestation of American problem-solving capabilities that identified tactical challenges, developed revolutionary solutions, and implemented them faster than enemies could adapt. Japanese forces, despite their courage and fighting spirit, found themselves confronting an opponent that could literally burn them out of positions they had considered impregnable, while remaining protected behind 30 tons of armor and American steel. The psychological impact proved as devastating as the physical destruction, creating panic that spread far beyond immediate combat zones as word of liquid fire capabilities reached Japanese troops throughout the Pacific theater.